Hello and welcome back, everybody. We are now going to jump right into a presentation from Orbitless Drives.
Hi, my name is Rob Isis. I'm the CEO and co-founder of Orbitless Drives, the next generation of gearing. I look forward to spending the next 15 minutes or so with you to introduce you to a truly novel technology, one that can be applied in many applications in your everyday life. I look forward to answering your questions and look forward to hearing from you about how you can take advantage of this truly revolutionary technology. Did you hear that high-pitched whine? It's a noise which you hear in many electric motor applications like dentist drills, electric toothbrushes, e-bikes, or EVs or electric vehicles. It's a common complaint and one of the key operating issues in the growing market for electric gear motors for all sorts of powertrains and actuators. From e-mobility to home automation, motion control in medical, defense, for air, land, and sea, basically anything that moves is part of the trend. For example, in each of the applications shown, there is some type of electric gear motor actuating or moving something, and they all have the requirement to be more efficient, more quiet, and generally smoother running. The problem is that the gear motor system has a flaw. While the electric motor is basically quiet and efficient, the gearhead that is used in many of these applications is relatively old technology and is the main sources of loss, mechanical interferences, and vibrations in the system, resulting in relatively loud and inefficient gear motor systems. The traditional planetary drive, shown on the left, is made up of a ring gear in red, a sun gear in the middle, and the planets that engage quickly around the sun in 6 or more places. The ring gear also acts as an amplifier of the noise, which is caused by tooth engagement, which is then transmitted through the gears to the ring, which is also the housing. The Orbitless Drive is a simple yet fundamental new gearing configuration. By removing the ring gear of the planetary system and replacing it with a secondary carrier, providing the output reaction, we have effectively halved the tooth engagement and frictions, reducing losses and internal speeds, resulting in the lowest noise and highest efficiency gearing configuration on the market. We started validating the technology in 2017 and have been working with independent gearing partners through various prototyping projects, as can be seen here with our first prototype done with Maxon Motors. We are also using a variety of advanced computer-aided simulation and modeling platforms to confirm the benefits. It's a continuing process, but as you can see, the early results are very positive. We've also been awarded multiple patents in the US, China, and Europe on our fundamental low-loss Orbitless Prime configuration and the high-ratio Orbitless Plus drive. The unique thing about these patents is that they were accepted with no office actions and no prior art on the technology, confirming that it's truly a unique solution. We also have a series of enhancements and other variations in the patent pipeline in all jurisdictions. Our licensing-based business model enables customers to license this core IP based on the geography, market, or whatever their business needs are. Further validation continues as we utilize the latest computer-aided engineering tools for various analysis, such as the Simulation X tool by ESI, which allowed us to identify and isolate the noise profile of the Orbitless against a planetary drive, showing our low-frequency noise versus the high-pitched whine you hear in a planetary system. We've also been using Romax Technologies' Nexus platform to further our understanding of the Orbitless Drive's unique kinematics. We continue to perform a variety of design optimizations, particularly around bearing analysis, deflections, and misalignment management. Finally, we are working with leading gearbox manufacturers to build high-quality prototypes. For example, this unit is our most recent build with Framo Morat, and we'll be testing on state-of-the-art systems to really understand the performance of the Orbitless Drive. And just like any other gearing technology, the Orbitless Drive is really a platform technology versus a single solution, and can be configured in a number of ways to meet the unique application requirements of each customer. Whether it's noise reduction, higher efficiency, or a more compact high-ratio design, we take the customer's application requirements and design a unique solution to meet their needs. At the same time, We're working on some standard reference designs that meet some of the more generic low-noise gearhead needs. For example, here are 3 solution configurations that we are focusing on due to their very unique benefits. The Orbitless Prime, which is our core technology for low noise, high efficiency. The Orbitless Plus, using belts or chains, a truly unique high ratio option. And our Orbitless Gearless, which is, as the name implies, a no gear 2-to-1 reducer or increaser that will make even the most seasoned engineers scratch their head. When it comes to NASA and the applications that are relevant, we have a lot of ideas of where an Orbitless can benefit applications in space due to their inherent benefits of low NVH or noise, vibration, and harshness, high efficiencies, and the ability to use alternate materials and some significant lubrication benefits. Electric gear motors are used as actuators to move satellite arms and panels, and in rover-like autonomous vehicles for powertrains like in-wheel drive systems, or actuators that enable arms on the vehicle to extend their reach. We also see a lot of opportunity in other air, land, and sea, including defense and industrial applications. And we're really just scratching the surface in these application areas and welcome your questions on where an Orbitless drive can fit in your product. As for current projects underway, we have a number of paid projects in the prototyping phase of development that are specific to customers' unique applications. From EV drives and actuators for doors and liftgates in the automotive market, to e-brakes for trains, robotic vacuums for homes, and medical device microdrives, there's a lot going on. As a more detailed example, we recently got approached by an electric motor manufacturer called Aurora Industrial Machines that is launching a new class of electric machines that had a particular need to have a very high efficient 2-to-1 increaser with a close to inline shaft. Orbitless offered a very unique solution for this application. We're partnering with them on the design, and they will be testing the solution with an end-user customer once the prototype is built shortly. Our model is to license our IP and designs to customers, which can be direct or through third-party manufacturing partners. This follows our Orbitless development program model, where we have a very structured path to take customers from the idea and innovation stage through an iterative design and simulation phase, a prototyping stage with various functional performance prototypes done, then preparing the final design for manufacturing and ultimately mass production. We utilize the latest computer-aided engineering technologies either internally or through a network of industry partners. How are we getting all this done? With a great team. We're building both an internal team and an ecosystem of global industry experts and design partners to commercialize this exciting technology. My co-founder and partner, Dr. Leo Stocco, is the inventor of the technology. He did his PhD in electromechanical optimization around robotic systems and is still a current lecturer at the University of British Columbia. The idea came to him when thinking about how to optimize and get rid of the hard-to-manufacture and expensive ring gear in a planetary drive. Another key member of the team is Laurent Belil, who is designing both gearing solutions and some CAA tools to assist in the specific development of Orbitless drives. In addition, we are building out a network of gearing-focused design partners from the automotive, aerospace, and industrial markets to implement Orbitless for their customers. Tech is based in Switzerland, has years of F1 and aerospace experience, and Vibon Lee from Advanced Mobility Products, based in Toronto, has been involved in automotive and aero application designs and builds for 20 years plus. Finally, we are adding industry veterans to our board of advisors, including John Jennings, who is currently Global Technology Director for Means Corp, a leading automotive drive component manufacturer, and in the past held similar roles at Eaton and Linamar. This ecosystem extends beyond our design partners and is really fundamental to our business model of primarily IP licensing with some design services. We work with industry organizations, speaking at conferences to educate the market on Orbitless. We're also closely working with CA design and simulation tool partners to get them to add support for the unique Orbitless kinematics to ensure a robust design path. We see our main customers as the gearbox manufacturers, who are generally working with end-user product companies to spec out the requirements and go build modules in the form of gearheads or gear motors that embed into the product companies that most of you know. For us, it's really about building partnerships in all segments of the market, and we're really just getting started. So now you may be asking yourself, how big is this market? The reality is it's hard to put an exact number on it because it is very fragmented with various sizes, materials, power scales, niches, and mainstream markets. Various estimates put the TAM, or the total addressable market, well over $250 billion, and and it's estimated that 25% of it utilizes planetary drives, with parallel access drives being the leader and niche technologies like harmonic drives taking smaller percentages. We estimate that the SAM, or the Service Addressable Market for Orbitless, to be in the range of 10%. And based on a typical royalty rates in this market of between 2 to 10%, it's a very healthy opportunity. So where are we today? Well, hardware takes time. We started this journey in 2016 when we started to truly understand the technology with first prototypes built and started to define which markets it applied to, as well as showing the basic concept to a lot of industry people. From 2017 to 2019, we focused on validation and education of the technology, building multiple prototypes with industry partners, showing off the concepts at trade events, winning numerous innovation technology awards at SAE's World Congress via the GAMIC program, Startup Canada's Export Award for BC, and many others. We also did many international trips to key market areas of China, Germany, Detroit, and others. We also presented papers and findings to a number of international industry and partner events during this time. We also participated in a number of local accelerator programs, including Creative Destruction Labs and in the Hatch program at the University of British Columbia's Entrepreneurship Program. At a number of international pitch events and accelerator programs, including TUSTAR in China, Startup Autobahn in Stuttgart, and most recently Tech Founders in Munich, which paired us with a corporate sponsor, Norbremse, who we're currently doing a prototype project with. We've also raised some angel funds from a number of top local angel groups, as well as participated in some Government of Canada technology funding programs, which has given us access to customers, mentors, partners, and the dollars at an international level. Results of these programs have led to multiple paid active projects for specific applications as discussed. Ultimately, this will lead to volume production and license revenue in multiple markets. Thanks for your attention. We hope you got some appreciation for this exciting technology and the numerous applications in the wide variety of markets that Orbitless can fit. Whether in space or on the ground, the future is bright for Orbitless. We have our patents, our team, have great validation, and are really understanding the true applications that Orbitless can benefit the most. What do we need next? Well, it's customers. We need customers that are looking for high efficiency, low noise gearheads for their electric motor applications. Secondly, we need partners to help design and actually build those systems. And thirdly, we need strategic investors, ones that really understand hardware, can take the technology and apply it in their own use, but also for their customers as well. We look forward to working with you all and hearing from you for your questions. Thank you and have a great day.
All right, thank you. Let's open it up for questions.
So I was very happy to hear that you make quieter. Can you comment on its impact on the lifetime of the gears? And are the quieter modes similar to a traditional gear?
Yeah, so basically the quietness comes obviously from the gear engagement, the reduction in the gear engagement. Now, from a durability perspective, what we do is using all the simulation tools, we'll basically build a gearbox based on what the desired gearbox durability is going to be. So we can change and use whatever materials that are out there to meet the durability requirement. Right. So in general, it's really about that customization of the design to suit the durability requirement. So if it's a really long-term one, we'll use harder materials and so on. Right. So that's basically how that generally works. There's no real single answer to that question.
But you have done lifetime measurements on something to show that.
Yeah, well, okay. We have done some on the original prototypes we did some like 1,000-hour tests and those sort of things. And what it showed was there was no, discernible wear problems in those initial tests, right? Generally, those are initial prototypes. Once we get into actual products for a customer, we'll continue to do different tests on their physical or their final applications. Right?
So for lubricants, lubricants would be the same as what you would use currently?
We're experimenting with that right now. We're doing a project right now, I mentioned with Norbremse, for a rail of e-brake solution where we're using a traditional lubrication that would be used in a planetary. And the initial results are already showing that the lubrication is treated much gentler than it is in a planetary. So that's allowing us to kind of play with lubrications to potentially use something different for a wider range of applications. And it's because it doesn't really mesh the gears as much, so it doesn't disturb the lubrication as much as it does in, say, a traditional planetary.
Thank you.
Next question.
This is Ramona. Hi. I'd like to understand a little bit more about your gearless design. You didn't speak about that too much. I'm wondering about the value it could bring to us when we deal with a very harsh, dusty environment like we imagine on the lunar surface. I don't know if the gearbox would protect it, but just share there about that.
Sure. The gearless solution that we talk about is a very unique solution. It's limited in terms of where it fits from the perspective of applications, because it's limited to a 2-to-1 increaser or decreaser. Where it fits really good is when you were talking about high-speed motors, and the motors are getting higher and higher speed, to do that initial reduction to half the speed, so then you can use a more traditional gearbox on it. That technology is literally brand new, and we're just starting to do the sort of analysis of it to really understand its core operating parameters. But it's really a unique solution, and for the things like you mentioned, dust and other stuff, because you're getting rid of the gears, we think it has a lot of potential for a lot of applications. But more to be done on that, and if there's interest, happy to engage with somebody on it. So,
thank you.
Sherman.
Yes, I wanted to get an understanding of the heat benefits that are brought about from your drive. I'm thinking about getting things out of the atmosphere and things being lighter, and not needing as much cooling equipment on because of the heat benefits you may bring about.
Sure. Yeah, I mean, heat has to do with sort of the engagement again and the speed of the gears they're going. Because we actually have that lower engagement and lower internal, what's called pitch velocity or internal gear speeds, we do suspect that heat will be reduced because of that. Now, again, some of those are in tests that we're doing right now. We haven't done a lot of testing on that because we're at the stage now where we've taken these design concepts, done some virtual prototyping, and we're just physically building some of these application-specific designs now. So they're in testing right now. We're seeing some results of that, but we don't have definitive answers on that yet, but we're getting close to having some really good data points on that. But it should be better. Yeah.
Next question.
Yeah, Robert, for your prototypes, do you have comparable planetary gear designs to test side by side for actual comparisons?
Yeah, exactly. So that's what most of them are done. The first one we did that I showed with Max on, this little guy here, was tested against an off-the-shelf, fully optimized planetary drive. And this was our initial prototype that we did, again, with Max on, so a high-quality builder. And that's where we showed the initial performance increase in terms of efficiencies and the lower noise. So we're actually comparing against a years-old, over-engineered, highly optimized planetary drive to our first prototype Orbitless, and we got good results. So that's obviously led us to do more, right? And just about every product we're doing now is comparing against some traditional gearing, whether it's or planetary and just the regular parallel axis drive. Everybody's always comparing us to sort of the incumbent technology.
All right. Any other questions?
Very quickly, Robert, this is Kurt. I started out life as a gearhead, so I really tried to dive into that and remember how to figure out the kinematics of gears. So I'm curious if you can just say a little bit about the relative efficiencies of your approach to the harmonic drives. I mean, a lot of the comparison has been with the planetary drives, and it's a clear mass savings there, but the but the harmonic drives are similar in some respects to what you have.
Yeah, so harmonic drives are really focused. There's been a relatively new technology as well, really focused at very sort of higher ratio, compact density type applications, compact power density applications. So high ratio being 50 to 100 to 1 is a sweet spot for harmonic. They have traditionally been relatively expensive and reasonable efficiencies, but not wonderful efficiencies. But really focused on what's called low backlash, which is really good for robotics applications where you need a very precise sort of movement, right? Our Orbitless Prime is really not a competitor to that because it doesn't fit that sort of ratio range. Our Orbitless Plus Drive, which is our high ratio compact design, we think that there's some applications there where it won't necessarily compete with the high end of the harmonic market, but probably in the sort of, if you need a compact ratio, 25, 50 to 1 gear head with, compact design, we can fit in there. So what we think is that we're just another tool in the gearbox designer's toolbox that's going to fit a segment of the market, right? And we're just trying to identify what that product market fit is for each of the different technologies. And that's why we say we're not going to replace everything, but we're going to slot in and fit in certain applications where we can really show off some good benefits, right? Against all those other incumbents.
Yeah, very helpful. Thank you.
Yeah.
How long do you think it'll take you to do market penetration?
So we've got, again, the first couple of years was really about validation, trying to uncover which applications made sense. Over the last 6 months, and again, we've been slowed a little bit by COVID just because getting things built in this time frame has been very difficult. But we've got literally 4 or 5 projects coming online now with application-specific builds, and those ones are being tested over the next literally, month and a half, 2 months. And then we'll have some real proof point application-specific designs that we can then start to sell to the market. Generally in the gear world, nothing is really off the shelf. It's usually off-the-shelf concept with a little bit of tweak here and there. So it just depends on the application space we're dealing in. In automotive, it could take 2 years to come up from an idea to a build. In a home automation thing, it might be 6 months. So we expect to see some products coming to market over the next sort of 6 months, right, with license agreements.
Anyone else? We still have a few minutes.
If nobody else has a question, I have a question about whether or not you guys have looked at either drone markets or electric aircraft propulsion markets. I know that one concern is that as drone traffic increases, noise from drone traffic is a big deal. And if you're, I'm not sure exactly how the noise hashes out in terms of what's coming off the airframe and what's coming out of the gearbox. I don't know what the drivers are there, but noise is going to be a big concern for high volume unmanned traffic.
Sure. So the thing in drones that people always look to us and say, well, you got to make a drone quieter. And the challenge is a drone is generally a direct drive solution, meaning it's just an electric motor with the fan, basically, or the blades. So there's no gearing in there traditionally in most of those motors. Where the gears are used in a drone is more for the camera articulation and such, which doesn't make a lot of noise relative to the actual, blade movement. So that's more of a blade technology sort of opportunity versus a gear reduction opportunity. So unfortunately, we don't really address that market specifically. However, we are looking at some more efficient sort of propulsion systems, like you said, for other aircraft and such, that are starting to use planetary drives or that have been using planetary drives, and we think there's an opportunity for that with our Orbitless drives. But that's still early sort of thoughts and concepts on that.
How far along have you been able to get with meeting certain engineering standards, and also have you looked into getting on the US GSA schedule for purchase?
Yeah, so we have done a little. The design or the standards that we follow are pretty much all the ISO or the what's called the AGMA, the American Gear Manufacturing Association standards. So in a design that we're doing, all the tools that we're using already have those standards sort of in there. So we don't do anything funky from a gear or material perspective. It's all pretty standard. It's just a reconfiguration of things, so it's easy to meet those sort of standards, right? What was the second question again? Sorry.
About the GSA schedule, the government.
Yeah. So we have not done much there yet, and really are looking forward to going down that path. Most of our customer projects thus far have been in either Europe, in the German market, which is big in the sort of mechanical industrial world. We've done a bunch in the automotive space, basically out of Detroit, but we really haven't kind of broached that into the government world yet. But ideally, through this and other recent initiatives, we can get in there and start to show off the product in that area.
That would be critical to make inroads on that side of the fence.
Absolutely.
Thank you.
Anyone else?
Robert, this is Ben. What question for the kind of like renewable energy market? Some of the largest and most like high-wire orbital gearboxes are in windmills, and you guys kind of showed that in your video.
Yep.
Is that a like target market for you guys? It's a lot bigger, obviously, scaled up from what you're doing now. But can you talk about that a little bit?
Yeah, sure. So that's a great question. We actually, when we first introduced Orbitless, everybody kind of pointed to the wind market saying they've got a big problem, they got big gears, you should go there. But you're right, it's a big scale opportunity and lots of torques and speeds and stuff that we didn't want to jump into first. However, since that time, we've actually been approached by a large wind power company that are quite interested in the technology, and we're sort of in initial discussions about some potential projects to do some due diligence and try to design a unit looking at their traditional gear structure, because they usually use different types of gearing stages within their systems, to replace one of them with an Orbitless for a more efficient system there. So we're starting that discussion with an interested strategic partner that has a real focused application. And that's kind of what our business model is. It's trying to find those strategic partners that have a deep understanding of their particular gear need, and then they see some benefit in Orbitless and then work together to try to develop it into a formal solution. And that's why we're really looking for strategic partners, that will help us design, and so we can work with their design team to design something specific to their application space.
Congratulations to the whole, to all the participants, and especially to the winners. Before we head out, I want to just give a big thank you to the NIA team. You guys have done a great job. This was my first event, and between the interactions that we had with the companies, but also all of the facilitating that's been done, all of the work and the coaching, and quite frankly, you guys holding my hand through this as I learned it too. I really appreciate all of you guys. And this was a great experience for me, and I think it's been a great experience for everybody. So thank you guys. I want to make sure that anybody who's watching the live stream right now, that you guys are aware that we have our Cycle 2 event coming up on October 15th and 16th. So please join us for that, where we will have another round of 10 companies showing us how their dual-use technology can benefit NASA while still stimulating commercial markets. Thank you.